Okay, so in section 5.1, we're talking about the mid-segment of a triangle. And the mid-segment itself is very easy to understand because it is simply the segment that connects two midpoints of the sides of a triangle. The segment, not the connect, the segment that connects two midpoints of the sides of a triangle. And so when you're thinking about this, you're always looking for, do I know if those points are midpoints? And then if I don't, how do I find out if they are? And then moving on from there. So the segment that connects the midpoints of the sides of a triangle. And so because there are three sides in a triangle, that means that there are three midpoints, which when we connect them, there's going to end up being three mid-segments, because that's the number of ways that you can pair up the 3 points into 2 points to create the segments. So that means that this is a mid-segment. So if we say that it's triangle ABC, and this is point D and this is point E, DE is a midpoint because AD is congruent to DB and AE is congruent to EC. So that means D and E are midpoints. The segment that connects two of those is a mid-segment. And then it turns out there are three of them. And you get this picture of a triangle inside a triangle, the triangle creating by the mid-segment. You could call it the mid-segment triangle if you wanted. And that is the what a mid-segment looks like. And then there's a theorem about mid-segments. In our book, it's theorem 5.1. And it's called the Mid-Segment Theorem. And the nice thing about this theorem is that it is pretty intuitive. When you look at this picture, and if I said, I want you to make a guess about some properties of DE as compared to BC, you'd probably could look at it and say, well, it really looks like those two lines are parallel to each other. And it turns out that that is a true statement, that DE is parallel to BC. And then you might also say, when you really look at it, it definitely looks like DE is probably congruent to BF. And that is also true because it turns out that DE is exactly half the length of BC. So the mid-segment theorem says that the mid-segment of a triangle, or a mid-segment of a triangle, is parallel to the third side, and half its length. And what that means, the half its length means that it's congruent to that segment created by those segments created by the midpoint. So when we look at this, we can see that, okay, so we said DE is congruent to BF and FC, but then we also know that DF is going to be congruent to AE and EC because DF is the mid-segment, EC is that third side, and so it's going to be congruent to those. And then we also know then that EF is congruent to AD and BD. And so what ends up happening, because of side, 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 we get these 4 congruent triangles: triangle BDF, triangle ADE, triangle FEC, so BDF, I did this in the wrong order, DAE, sorry. And then FEC. And if you notice, these are in a very logical order. They are all oriented the same way. And so I started with the one that's next to the 2 tick marks and the 1 tick mark, and then went up to the one between the 1 and the 3, and then finally at the F. And so the 4th triangle, the one in the middle here, that one is also going to be congruent, and it's going to be the one that says starts between the first 1 and 2, and then goes to the 2 and between 1 and 3. So it's going to be congruent to triangle EFD. And so those are our congruences that happen. And because of that, or because of the fact that we have parallel lines, we also know then that these angles are going to be the same. So those 3 angles are the same. And then that it's also the same as this angle up here. Let's put those in red so we can really see them. So these are all going to be the same because of congruent triangles and parallel lines. We also then know that these 2 angles are going to be the same. And they're going to be the same as this one inside the middle triangle that's kind of oriented differently. And then these three angles are going to be the same, and which means it's this one as well. And so you can see how there's lots of commonality between these triangles. So when we try to solve equations, we utilize those principles. And so DEF are midpoints, which means we got this mid-segment triangle connecting those points. AC, the entire length here, is 3x plus 2y. And so that's going to equal twice DE. Or you could say that DE equals half of AC, but it's going to be easier to write the equation as 3x plus 2y equals twice DE, which is 46. And then we know that CD, which is going to be 3y, is going to be the same as FE, which is 27. And so we're going to get 3y equals 27. So that's going to give us y equals 9. We then can come back up here and get 3x plus 18 equals 46. So 3x equals 28. And so x equals 28/3. And so that's how you use the fact that the lines are, the mid-segments are half the length of the sides to solve some problems. And then we can also solve problems given angle measures based on what we talked about. Again, DEF are midpoints. So that means that they are mid-segments. If angle A is 67, based on the parallel lines, remember these two are going to be parallel to each other because of the mid-segments. By corresponding angles, we would know this is going to be 67 and this is going to be 67. And then what we talked about before is that this one up here is the one that's going to be also 67. You're given that DEF is 68, and so this angle is 68. Well, that's going to be the same as this angle, which means it's the same as this one and this one. So all those are 68. And then the third angle in this turns out to just be 45 because 67 plus 68 equals 135. 180 minus 135 is 45. So we can fill all the 45s in. So angle C turned out to be 68 degrees. Angle B turned out to be 45. EDF turned out to be 67 degrees. And DFE turned out to be 45 degrees. And so that's how you can use the fact that you have parallel lines or that these triangles are congruent, like I showed you, to solve